Okay, welcome all of you back again. Let us start with some code demonstration of lambda functions. Just to briefly touch upon what I covered about lambda function. It's a single line function, lambda, parameters. We don't put a parenthesis around it, colon, body in an expression, only one expression. Now this whole thing returns a function object. There is no name to this. This function object that is returned can be assigned to some ID which can become a name. Now this we can use it to invoke the function. We can in fact use this lambda whenever we want to have a small expression to be expressed as a function, and especially if suppose you are interested in passing as a parameter, we can create a function and pass it as a parameter to a function which can be called inside. So that's all about lambda. And then these parameters could be any type, no parameters also allowed, of course. And then you can have keyword arguments as well as positional, multiple positional arguments as well as keyword arguments. It will accept it. Okay. Only thing is the expression has to be a single word. That's only a restriction on defining a lambda function. Now let us see a demo of this. So I am not going to type function. So let me use this, whatever I have written. Now what are we doing? This is about lambda functions. Lambda is the keyword, parameters xyz. And remember one thing, this is when we are is equivalent to a defining a function. So it's not going to be called when you do this. It is only defining a function. Now we are assigning that function object which is returned by this lambda into this label. And what does it do? It takes three parameters, it multiplies them and gives it. Okay, that's what is the job of this lambda function. We are assigning a name. Okay, so it's not that anonymous. It was created anonymous, but it was given name after it is created. Now we are calling it with the parameters. Now this is where the invocation happens. So you see that it multiplies this number. Okay, all these three parameters, it is getting multiplied. So that's all about lambda. So let us see some more examples. Now I can have a default parameter also given. Okay, so what happens when this object is created? All the details about what parameters you are giving, what default values you are giving, they are all captured when it is packaged as a function object and passed on. So this similar to our closure where I told about the non-local variable information is also captured, the data along with the function. Here you see that the default parameters is also captured when this function object is created and passed on. So if we call it with 1 and 2, this will take a default value 10 and the output will be 20. Okay, so this information is also there. We can give there is no restriction in terms of what kind of parameters you can pass it to a lambda function. That's what I wanted to explain that. Now I also said that it allows variable number of positional arguments, which is nothing but args. Now this is a lambda function again. It takes variable number of positional arguments, and the body is this. So it's like a comprehension. The body of this function after the colon, whatever you write is the body of the function, and it has to be in a single expression. I have captured it under list. That means it is going to create a list like a comprehension. Whatever parameter has been passed to it, or positional parameters, it accesses each of them and then puts it in the list. So this function, lambda function, what does it do? It creates a list with all the parameters that have been passed to it. Okay. Now, when you call it, this is what you will see. Okay. It is creating a list with those values. Okay. Now, you can even pass a variable number of positional arguments, and it constructs this list object with that. That's all. Okay, this comprehension which I have mentioned. Now let us see, can we do something with the keyword argument? Of course, keyword arguments also, variable number of keyword arguments also allowed. Now what does it do? You pass a keyword argument like this. Okay, now what we can do is we can use one of this dictionary syntax, because you know that keyword arguments are passed as a dictionary entries. This go in as a dictionary entries. We take the keys and form a list of keys. Only the list which has only the keys, that is 1, 2, 3 will be there. So I can create a list with those keys. Okay. So what does it mean? Okay, when we say print, actually it is returning whatever has been done here. Okay, this which I have not mentioned, this lambda construct itself returns a function object, and when you execute the function object, whatever is the output of this expression is returned. Okay, so that's why we see that when you print by invoking the lambda function, we are able to print the key, the list, what is coming out. So what is in the expression has been, whatever is the output of this expression is returned by the lambda function. There is no return statement, but it is implicit that this expression, when it evaluates, that value is returned by this function. So that's what you see here. The values are printed here. We are just printing those values here. Okay, I hope this is clear. Now let us see some more examples of I think this is same as what I told. We can either take keys or values. So I am using the values function of the dictionary and then forming a list. So this will form a list of all the values that you have passed. Okay, you can do any other thing. I'm just demonstrating a few of them. Now let us look at this, another example. Can it construct a key value pair? Okay, you know that it is items. We are forming a list of key value pair dictionaries. Okay, list of dictionary elements, and we use key value from the items, because you know that items returns two values, both key and values, and I am constructing a dictionary using this key value in a list, and that list is returned by this lambda function. So when you have the same thing, you get a list of dictionary objects with those key value pairs. Only thing is, this whole thing has to be as a single expression. So, but it accepts either keyword, variable number of keyword argument, or positional argument, any number, you can do it. Okay. Now, other usages of lambda function. So why do we even need it? Now I am going to show you some examples to demonstrate the lambda function could be used for various purposes. Now imagine I have created a function, my function, which is accepting a value n, which returns a function object. So this my function, when you invoke, it is going to return a function object. What is that function object? This is the function object. Okay. What does it do? It takes a parameter, whatever is the parameter, it is going to do the power of n. Okay, to the power of n. You know that it is to the power. So a to the power n. Now what is a? A is the parameter passed to the function object which is getting returned by this my function. Okay, a is the parameter to the function which is getting created here. It is nothing to do with this parameter. This function accepts this parameter and that is pushed here. It is put here to the power of n and it creates a function. Now there are undefined values. N is also not defined here because unless you invoke this function, n is not known. When you invoke this function, my function, with some parameter, then n will be known. Then it will put a value for n, whatever has been received as a parameter, and then this function is created. Now, what is not known to this function object? The values of a. That will be passed on when you call this function with a parameter, one single parameter. So it accepts one positional parameter and there is no default value. So you need to pass one parameter. Then a is also resolved. Now this expression can be evaluated. Till then it is not evaluated. Okay, even here it is not known. N is also not known, a is also not known. But when you call this function and create a lambda function, n is known, a is not known. But when you are calling this object, you are going to anyway pass the value while you are calling this lambda function. Then a is also known, so this can be evaluated. And default, I said that it is going to return that value, whatever is computed in the expression. So you will get to the power of something. So where do you use it? We can actually give a different meaning to this function based on what value you are passing. Okay, maybe you can find a square of this value or a cube of this value based on what you pass. Now this function object, you can name it differently based on what you have created it for. So it is having a multiple instances of this object is created with the different purposes. Okay, so let us see how we can use this lambda function for our benefit. Now suppose I want to construct a square function. What do? I use this my function for me to create a square function. I pass 2 here. Then what does it happen? What does it do? It creates a function which is a square function which computes the square of what is passed to it, because it is going to do a power of 2 to whatever is being passed to the function. So this square function, I name it meaningfully because based on 2 I am calling it a square function. Now if I pass 2 to that, what happens is this function object is nothing but this is the body, and when I pass 2 here, 2 to the power 2, because this 2 is here, which is taken as a n when this square function is created, and this is a parameter to a, so a to the power 2 will be computed. Okay, I hope you are able to understand this. 2 to the power 4, 2 to the power 2 is created. Now how do I use it for different squaring? Okay, we can do that. It's not a difficult job. If I pass 4, now 4 to the power 2. Already the square function computes the square of whatever has been passed to it, because I have already created this object by passing 2 to it. Okay, this is how we can actually use this lambda function for behaving as a different functions. Okay, based on what parameter was passed initially to that function. Okay, so it is 4 to the power 2. Now similarly, I can also do a cube function, which is already done, and I'm sure this is the next logical way. Even power to a power, no. Now you see my function 3, which is computing a to the power 3. So that I am calling it as a cube function. Then if I pass 2 or whatever number, it is going to compute the cube of that number, whatever we pass. Okay, so this is the one possible method of using the lambda function, which I explained before we started this 11b. So lambda functions are mostly useful for cases in which you would otherwise need to define many tiny functions and remember what you called them all. Okay, what name you called. Okay, what was the name of those functions. Now lambda function actually solves that problem. Like you can just create those lambda functions and then use it and throw it. Okay, so this is the end of 11a. I hope there are no questions. Hopefully, now let us look at some more built-in functions for today. I'm going to some of this. I saw some of you using it already in a assignment, but still, I thought zip. I think most of you may be aware of, but at least those who are familiar with Python will know. But this is for everyone. Okay. Now we are going to only look at few of these built-in functions. There are many which many of them we have seen already. Okay. This we have seen a lot of many things. Hash we have seen, help we have seen. I think frozen set we have seen. There are many of them. We have range and length and all those things we have seen. I am just picking up some of those built-in functions. So what is the built-in function means? You don't need to import anything, any special library, which is the Python language or the definition itself has those functions defined in the language. And remember, all of them were not introduced in the earlier versions. Python version 3.5 onwards, I think 3.5 or later, they include all these functions. Okay, they have really improved the built-in function support in Python with the latest releases. So the Python interpreter has a number of functions and types built into it that are always available. When I say available means you don't need to import anything. You can just use them without any issue. So we will see 4 of them today. Okay, maybe 2 we will see before a short break, and then the other 2. This will more or less stop with all the discussion that we have with the functions and parameters and everything. Okay, all related to functions are done, I think, with this discussion. Okay, so sum. What is the sum function? Of course, it's very obvious. It is going to compute a sum of something. Now, you see something funny here. This is iterable. This iterable object means anything like list or a dictionary or a set, tuple, or okay, this is set actually. We can call it as a set or a dictionary. Okay, something colon something. Okay, so any of these are all iterable objects which can be iterated on. And then what is this? This is an indicator, a backslash, saying that all the parameters to its left, okay, are positional arguments. So you need to have a positional argument only. Keyword arguments are not allowed. Okay, and then what is this? This is a keyword argument with the default value 0. The name is start. So after this, you can have one parameter. Okay, that's only one. There is nothing. But if you don't give it, it will be assumed to be 0, or you can give, of course. Now, what is this? The function says it is a sum of iterable objects. So suppose if I am passing a list of numbers 1, 2, it is going to do 1 plus 2. Okay. Now, comma, if I give 5, it is going to add 5 also to it. Okay. So this is another. Actually, it can be useful for kind of machine learning where you want to add a bias. You normally do, all the weights will be passed maybe as a list, and then bias will be added at the end. So this sum function will be useful for implementing. If you are having machine learning, I'm sure all of you are aware, weights are there, and then at each level there is a bias. But there is a multiple connection, dense connection, or whatever. Based on that, you will have multiple weights coming in. So we can use this sum function to all, this weights multiplied with the whatever output of this earlier layer into this iterable object, and then any bias can be given here. Okay, and mostly this sum function, don't think that I am showing you some integer value. It is possible for doing the same operation on floating point also. So when we are talking about weight and bias, it has to be floating point numbers. So this will help you in terms of even implementing it. That's I don't know whether anybody is using this, but maybe when you need to implement this, most probably we will be using a TensorFlow library which is already done by someone. But if you need to build your own machine learning model and then you want to do it, maybe this is a good idea where this start can be used for taking care of those additional biases to be added to the node. Okay, so what is if you don't give it, it will be assumed to be 0. That means it will only add the values of iterable objects that you have. Okay, there are different ways you can use it. I am going to use the show those usages in the demo now. But before that, let me complete all the explanation so that we can look at the implementation. Sum starts and sums. It sums, as it's a verb. Sums start and the items of an iterable. It is adding up the start and then the items inside the iterable from left to right and returns the total. Okay, this is doing the addition of all these values, but it is doing it in this order. Sometimes the order doesn't matter, but if you are doing specific to some floating point numbers, maybe order matters, because when you are adding something, where smaller values might get lost. The order matters when you are doing it. But in our Python case anyway, integer is also expandable. Order doesn't matter at all, but the implementation says that it is going to be adding it from left to right and returns the total of whatever it has been added. So iterables could either be integers or floating point. As I mentioned, it can be either integer or floating point. Another point I want to mention here, suppose if you have all integers here and the start you are given as 0.0 or 2.0, then the result will be float. Okay, because you know that any integer will be promoted to float if any of those values are float. So it doesn't matter whether you are only using integers here and then a float here, or all floats here and one integer here. The result will also always be the high-end representation, which is float can represent much more than what can be done in integer. So we have a float value which is coming as a result. Now start value is also added with the iterables, as I mentioned. If given, if you have mentioned it, it will be added. It can also be either an integer or floating point number. Even the start can also be integer or floating point, and iterable objects can contain integer or floating point, or a mix of both. Okay, or they can have a mix of anything. So it will take care of doing all the floating point addition if there is one element which is a floating point in the list or in the number. The iterables items are normally numbers, and the start value is not allowed to be a string. Now all the iterables you need to have it as a numbers, and you cannot have start as a string. Okay, don't pass 2 here like this. You have to pass an integer object. Okay, so it doesn't accept strings. A slash in the argument list of a function denotes that the parameters prior to it are positional only. So here it means that they are positional parameters. You cannot have a keyword argument here. Okay, that's all about the sum. So let us look at the implementation of this. Okay, now let me keep that file open so that we can use. Okay. So sum is a built-in function that calculates the sum of the values in its iterable numeric, which could be int or float as argument. If a start value is given, that is also added to the iterable object. So this is the syntax, and I am giving a list of numbers. I am passing only num list, then it will perform the addition of these numbers, and I give a start value as 10, then it will add along with this plus 10, otherwise plus 20. So that's all, you get it. 15, 25 or 35. Okay. Okay, now let us look at floating point. Now just to verify whether it accepts integer and floating point mixing. So let us, I don't think it will have any issue. So it doesn't matter whether you pass everything floating point or one number as integer, doesn't matter. It takes care of adding those numbers. And similarly, even if you are passing it as an integer, if these are all, any one of them is float, you will get the result as float. Okay, that's, I mentioned it already. Okay, now what about this auto promotion? I told you. Now what about this print sum num list? I am passing a num list with a integer. Num f list is for floating point numbers, num list is integer, and only this is floating point, then the result is going to be floating point. Now I can also pass a tuple instead of list, any iterable object. I am explaining that it can be done with a tuple also. Okay, and then let me explain this before we give a error condition. Now num f list floating point, and then a floating point number. Now I am not mentioning start here. Okay, start equal to, I am not passing it as a start equal to, I am just giving this, I am not giving a keyword argument. I am passing this value, which is supposed to be a start value, so it takes care of that. Okay, it takes this value and then adds it with the rest of the num list, whatever you have passed. Okay, now what are the error conditions? Let us look at the error condition. As I mentioned, there should be a positional argument before, only one positional argument. Now suppose if I pass 2, you get takes at most 2 argument, 3 given. Okay, you cannot pass more than 2 parameters. And now suppose this is error, of course. Now let us see one more thing. I have not tried it, so let me see whether this is if I give you one list here and another list again, same list, does it accept? It will not, because here it is expecting a single number, not a list here. Okay, can only concatenate list, not to float. Okay, to list. Okay, this can only concatenate list to list. So we cannot do a floating point here. It is expecting a floating point number or some integer number, and you cannot pass two list here. Okay, this is also another error. Okay, you have to be careful about what is it defined with. I already mentioned that it is defined as this, so you cannot have a list object here. It has to be some integer or a numerical floating point number. Okay, it can't be iterable object. Only one iterable object is allowed. Okay, so that's why I'm saying a two iterable objects also it doesn't accept. Okay, now what is the other one? Can I pass no argument? That is also allowed, no issues. I can say empty list with one value, it will return just 4. I can just pass nothing. Okay, that's also allowed. It will give sum as a 0. And if I don't pass anything, it assumes it as a integer number, so it gives 0 as a value. So you can actually understand how the interpreter is treating these values and how it is behaving. We can easily find out. Now let us look at some more error condition. I can't pass more than one parameter, as I already mentioned. Now what about this? Sum of 4. Here it is expecting one argument. Okay, this first argument has a positional argument has to be given, which is to be iterable. Okay, you cannot just say start value and then expect it to work. You have to give a null list or a null dictionary, some iterable object. Even if you don't want to pass anything, you need to have a something here. Okay, it is a positional argument. As you can see, it needs to have an iterable object mentioned here. Okay, like this you need to give with one value anyway. But if you just pass only a start value, it will give an error. Okay, int object is not iterable. It assumes this first one is to be iterable object, which is not possible, so it gives an error. Okay, I hope all the possible usages are understandable. Now let me show you one example of maybe I'll take everything. Let us understand what I am trying to do. Now, sum argus is a function name, a variable number of positional arguments. I am passing it to sum. Okay. Now, is it acceptable for sum? It is yes, because argus is a tuple here. Okay. So it's an iterable object. So sum accepts the first parameter as an iterable object, and I am passing this argus, which is a tuple received is as it is passed to it. So it is an iterable object, so it accepts. And now run with positional argument, another function. What I am doing, I am passing a function object. Okay, we will connect these two soon. Let us understand it individually. Run with positional arguments is a function which is accepting a func. Func means some object, function object, and then the argus. So now is similar to what we saw in the dictionary, like function object and the argument we are passing, and we are calling that here. So I'm passing a function object separately and the argument to be passed to the function separately, and this function puts them together and then returns the result out. Now, what is this function object? It can be anything. Now, what I am passing is sum args. Okay, this is the function object I am passing. Now, what is that sum args? Sum arg is nothing but this function. Okay. Now, let us trace it now. I am passing a sum args function, which is nothing but this function as a function object here, and then passing some values. Now all are all positional values, which will all be compressed into a tuple, and then it goes into this function. Okay, this function object is passed, and a tuple of this positional arguments are passed. Now where am I calling? I am calling this function. So this is the function. What does that do? It calls this function with the argument. So it is going to call the sum args, which I am passing this function, and it is going to pass this as a tuple to that function. Now it is internally going to be calling this function, and that is going to call the sum with the tuple. Now what does the sum do? It is going to add up all these numbers and then return the result. So that result will come from this, and this returns, and the result comes. So finally what you are getting is the sum of these numbers out from here. So we are calling multiple function objects are created here and then getting called. I think the flow is easier to understand, and you are getting this. Okay, I hope this is clear. And you have to make sure that sum is always passed with an iterable object first. Okay, that needs to be taken care of. Okay, now that's one way of using the sum function. And then let me show you a dictionary. Now what happens when I pass a dictionary to the sum? Because there are going to be two values, right? So we don't know what is it going to do. So suppose if I am calling sum can add the elements of list, tuples, sets, and dictionary. These things are easy to understand because they are going to have only one single numbers, single items. But dictionary is going to have a key value pair. Now is it going to add the keys or the values? So obvious that key is more important in a dictionary. So when I am passing a num dictionary with a number here and a string here, a sum function adds all the keys, that is these integer values, because they are matching with the numbers, numeric number, and it is also an iterable object because the dictionary itself is an iterable object. That's also satisfied for the sum function. So it accepts it. Only thing is, based on the object type it receives, whether a list or a tuple or a set or a dictionary, it looks at the proper value and then checks whether they are proper in numbers, and then they sum it up. Okay, so it just adds these numbers and then gives you the result as 6. Now, if at all, I can just one more thing I can try, which I did not try earlier. So suppose if I make one of the keys as a string, okay, dictionary allows a string to be a key because it's a immutable object. Okay, here it is, it accepts, dictionary is okay with that because it can compute the key for it, hash for it. But will the sum accept it? Because it is looking for the keys only to add, and I mentioned it that somewhere it is not possible unless there is a numeric number, a float or a integer. So a string is not a int, unsupported operand type for plus, int and str. Okay, this is int plus str is not allowed. Int plus float is allowed, int plus int is allowed, and float plus int is allowed, but int plus str is not allowed, so it doesn't accept this problem. Okay, there is an error. So let us keep it as it is so that you know that there is an error when you invoke it like this. So you should know sum, what you need to call it with. Okay, so that's all about sum. The class has been very quiet for a long time. I hope everything is going in. Now let us understand zip before we break. What is zip? Zip is putting together something, right? What we 7-zip or WinZip, what we do, we put different files, put them into single file. So here what is happening is I have multiple iterable objects. Okay, some elements are there. I want to zip them all. That means all the first element of this I want to put it together. All the second element of this different iterable objects I want to put them together. So I want to create a tuple of all the first element, all the second element of all the iterable objects I pass. Now there is a star before iterables. That means I can pass any number of iterables to the zip function. It's not only limited to 3. I can put any type of thing. I can mix it also. It's not that all of them need to be list. I can have a list with a dictionary, with a set and a tuple, whatever. As long as they are iterable, even the string, I can even pass a string. So it is taking multiple iterable objects, okay, the zip, and then it goes through each of them. It goes the first element, it gets the first element of all of them and forms a tuple for that. And then it goes and looks at the second element of all the iterable object and goes like this. So a zip is something like it. Sorry. Okay, I have not put 1 second. I have not put animation. It looks very bad. Okay, done. Okay, so let me repeat again. Zip does multiple, any number of iterable objects can be passed to zip. What it will do is it will pick up all the first elements and then gives you a tuple, okay, and then it picks up the next element and then forms another one. Okay, so it actually groups different elements and then gives you. So these are all very useful for data science applications where you want to group all the different elements in a different list or data items, you can use this zip function for doing that. Okay, so let us understand more about it. Now I will talk about a strict false. I have not given example. We'll see later on. It iterates over several iterables in parallel. Okay, they look at different things, not like one for loop, one item in. No, it doesn't do one for loop for everything. All of them are in parallel. They are iterated over. Okay, that's another different way of performing uh, different list. Okay, always we have seen that it iterates over a particular list or a particular iterable object, but here it does a iteration on multiple iterable objects in parallel. So it accesses multiple objects simultaneously, okay, and then group them all together, producing tuples with an item from each one. Okay, it returns a zip object. The object it returns is a zip object. It's a separate type, a separate class. This is an iterator of tuples where that whatever zip object is an iterator of tuples where all the values you have passed as arguments are stored as pairs. So this here means zip. Okay, zip is an iterator of tuples. So it's a tuple object. Okay, whatever parameter you have passed, their values are grouped together and then a zip object is created. Okay, so it's a beautiful, you can find a lot of use for this kind of a thing. So the zip method continues executing. Now you don't know when you are passing a multiple list, how many elements are there in each of them, we don't know. It may have 3 elements, it may have 5 elements, and this may have 2 elements. Now what does it do when you are not able to, when you don't have anything, what how does it group it? It can group this first 3 elements, it can group easily. Okay, sorry, first 2 elements it can group easily, but when it comes to third element, these two are having it, but there is no third element here. Now what does it do? It doesn't give you a tuple with only this and this element. Okay, which is not correct as per the requirement. Okay, we want contribution or the element coming from all the parameters that you have passed. When there are not sufficient number of parameters, what does the zip do? It stops. It doesn't go further until all the elements have at least one contributing item coming from each of those parameters. So this happens executing until the iterable objects are fully zipped. Okay, this happens when the iterables are exhausted. Okay, when you have it will continue to execute until iterable objects are fully zipped. That means, suppose if you have all of them, many number of items, then it will go until all of them are zipped together. But if any of them is halfway through, then it will stop there. Whichever is the minimum number, that many only will be grouped. In other words, the zip method stops when all the possible pairs are created. It will stop only when all possible pairs are created. If the zip tuples values are to be unzipped. Okay, now I talked about zipping the values. Now what if you want to unzip them? There is no unzip function. If you have seen that there is no unzip function, but you can do a similar equivalent job with the unpacking operator called asterisk. Okay, I will explain that also with an example, how you can unzip all of them, okay, after you zip it. Okay, so that's what I'm going to demonstrate before we break now. Okay, let us understand it with the code now. I hope this zip you understand. So let us quickly look at okay, now let me steal from here to save time. Now we are getting into zip function. I am passing a num list, a num name list, 2 different iterable objects. All of them, both of them are having 5 elements, no issues. So I need to copy some more. Now what I am doing, I want to see, I am passing this to list to the zip but I am not taking the value what is coming out. I am just finding. I told that it is returning a zip object. So I want to verify whether what I am getting is what type of object it is. You can see that it is class of zip. It's a zip object belonging an object belonging to a class of zip. So I'm not using the tuple which is coming out. Now let us do that. Now how do you use it? Okay, now how do we use it? I am zipping it, the num list. Okay, what is the value? Two lists we have, num list and num name list. I am passing the name list first and then the num list second. The order matters because it is going to go in the same order in which the parameters have come. So it is going to group this and this and this. Okay, this is going to group it like the tuple, and tuple is not mutable. So you are going to get a tuple which is grouped like this. Okay, now what I am doing is I am, after it returns, I am going to have this. No, that I am going to is a zip object is an iterable object. So I'm going to iterate over that tuple, and I'm going to get this thing filled. Then it is going to print those numbers. So let us see. Now what is happening is I am printing this and this. So what is happening is it has created an iterable object. A zip object is an iterable object which is having all the tuples inside them, and I am going over that in the for loop. So zip is done only once. Don't think that zip is called multiple times. Zip is called only once, which has already created. It has gone through it, this particular list in parallel and created the zip object, and then that zip object is iterated over in for loop, and each one of them are printed. Now I am printing those individual elements in the tuple like this. Now if suppose if I am passing one more, okay, let us do that. Suppose if I am passing one more num list, what happens? Now I need to give properly, expanding it because too many values to unpack. I have not given this. So num1, num2, because each of those tuples are having 3 values. So I need to give 3. You remember that when we were tuple to this, when we do, we need to give those values exactly same as how many are there. So then only it will work. Now the num list is looked at again. Okay, it doesn't matter whether you are passing it twice or not. It doesn't matter. We are having a tuple with 3 elements, so I need to assign those 3 elements into some variables, and then I am printing it here. So this is how a zip can be used. Okay. Now let us see few more examples. What is this? I am having more elements here than this. So as I mentioned, it will only go up to only whatever is minimum number. So it will only pair these 3 elements, and it doesn't take care of any of this. Okay, it just ignores those elements, and I am doing only 2 lists, name and num list. I am passing the name list first. Remember that. Now I am changing the order. I want to tell you that. Sorry, did I do that? Okay, I did the same thing there also. So name list. Okay, I will do it later on. Order is changing it. Now name list and num list, it only goes up to 3 and then ignores this other elements and gives you the tuple iterable object. Okay. Now what do I do? Now single, suppose if I give a zip with a single element, does it accept? Yeah, it is okay. You don't have anything to parallelly access it, so it accepts even a single element. It accepts. Why is that? Why does it accept? Maybe we have a reason for it. It is a star. Okay, so any number of iterables can be there. Okay, so it is different from here. Here's only iterable was there. That's why it was insisting on one positional argument in sum. Whereas here there is a star. Multiple iterable objects are accepted. Even none is also accepted. That's why even zip, null zip, print with zip should work with no parameter. yeah, it doesn't do anything. Okay, calling with no parameter is also accepted. Okay, so it's very obvious from the definition itself, but it's still better to verify it. Okay, to be sure what it does and what doesn't do. Now, what about the string? Is a string is also a iterable object. All of us know. What does it do? It is going to do this. Okay, now it is going to print a tuple object with a single element is going to be printed like this, because if it doesn't have this, you will think that it's just a parenthesis or a parameter. You will not know that it's a set object. So even always it is a set, sorry, tuple with a single element is also always ended with a comma at the end. So to know that, to show that it is a tuple and not a parenthesis, a function, parameter or something like that. So now what if two strings are to be, this is actually useful for string manipulation, zip function. So you can do this, small and caps, you can print it, so that you can take one here and one here. So string is also a iterable object, all of us know. Now one more thing, I just wanted to say that one is a dictionary and one is a list. Okay, oh well, it's a set, sorry, not a dictionary, it is a set. So I am passing the set and the list. It doesn't matter. They need not be same. So just to make sure that different iterable objects can be passed, I gave one example. Now finally, one more. I don't know whether I have tried everything, but to the maximum possible, I have tried to give example for every one of them. Now look at this. Unzipping. Yeah, I mentioned about unzipping using the star operator. So one example for that. When you have a zip with a num name set, this is a one, and a num list, you have created a zip object. Okay, you can iterate over this and then print it, but now I want to again reconstruct what I have passed. Okay, new name list and new num list I want. Okay, actually name list, I don't know whether it forms a list or not, we'll see. What I need to do is zip with a star. Okay, it is not similar to our args or something. It is like indicating the zip function to unzip this zip object. Okay, this is a zip object, you are asking it to unzip it, and I know that it has been, you know that there are two pairs of elements only can be there. Okay, or three also can be there, but based on how you have constructed it, you have to call this, otherwise unpack will be an issue. Here I know that it is packed with two values. We saw that it is packed with two lists, going over the two lists. So they are going to have a tuple with two elements. So I am saying giving a list, so that I am putting them to all together now, all the zipped object. Now let us see the output of this before we see what is happening here. Unzipping. Now you see here, it has reconstructed the previous one, but the order of this is different. Okay, that is because of what reason? Let me think. Because when we constructed it, we gave it, but here you see that it is always giving a tuple. Okay, it doesn't give you any other thing, list or district, dictionary or something. It gives you always list, set, tuple, and it gives you going over the num zip object, and then gives you put them all together. Okay, they were all to, like individually, 1 and 1 was there, and 2 and 2 were there, and 3 and 3 were there. This, it was like this, and then they all grouped together like this. Now this is how you can unzip them. Okay, I hope this is clear. What the time? Okay, we have reached 8 o'clock. Any questions, guys, from any of you? Any questions so far? I hope understandable. Do you want a break now? I don't know whether this yes is for the understandable question or break, Swati. Okay, I'll ask break. I presume that yes is for understandable. Do you need a break now, or can we continue? Yes, 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 yes. Okay, fine. So let us continue with byte array and bytes after 10 minutes. Now let us look at something more deeper into bytes. Okay, I'm going to talk about two functions. Okay, again I have not put the animation, so let me do that. I don't know whether this has animation. Yes. Okay. Now, what are the byte arrays? Okay, bytes and bytes arrays both are there. Bytes. There's only a subtle difference between these two.
Sir, you are
Yeah,
not
go ahead.
audible.
Oh, sorry. I forgot to unmute. Thank you. Okay, thank you. I forgot to unmute. Okay. Now, okay, this should have been small letter. Okay, actually. There's a subtle difference between these two. This is immutable, whatever it returns. This is mutable. Okay. Now, why are we talking about this bytes and byte array? Let me give a idea behind it. We want to see what happens when you create an object. Is basically the object is itself in the memory, right? Object memory. It's part of some object memory. When you say string, it's actually basically in a C we have only a list of characters, and then maybe based on the encoding either ASCII or UTF-8. Okay, different encodings will be there, those characters. In C we used to have a null terminated string. Okay, null terminated string, whereas here there is nothing called null termination because there is a length maintained for every string that you have. The string object itself is not so compact like what we have seen in C. It occupies a lot of space, quite a lot of space. May not be too high, but a little more than what a simple string in C occupies. It string in C occupies only the number of characters plus one for null character. That's all. That many bytes are reserved. Whereas here there is no null terminal, but there is a length maintained so that you know that there is how many characters are there in the string, and there are methods for that. So it's an object everywhere. Now, suppose if you want to handle or modify some objects, you need to call those methods. Okay, we will come and we'll talk about methods and classes soon. Those who are new to object-oriented programming may not understand the class or methods, but it doesn't matter. It's a data, and methods are functions which are grouped together as an object. A class is a template kind of a thing, a structure or something like that, and object is an instance of the class. So multiple objects can be created for a particular class. Like a string object, you can have many string objects for a string class. So if you need to operate on these objects, you need to call those methods, and then they operate on this object memory. And it has its own performance limitation because you need to pass this pointer, that is the pointer to the object, as well as the parameters to the method, and then they go and operate on those data area which is part of that object. The methods which are there is common for all the objects, which is part of the class definition. But our data will be unique for each of the objects because you have different strings with different content in them. But when you are operating these string objects through the methods, it takes a lot of time in terms of performance, in terms of clock cycles, or in terms of time taken for manipulating the objects. But if you want to do it like most efficient, what you are doing is actually operating on this memory area, which is only a small portion of the data area, right? So if you want to do it directly into those memory area, there are some memory views, and then byte arrays. Bytes are all different ways of looking at the actual content of those objects, how they are laid out in the memory. Okay, we are not exactly seeing it, but more close, much more a closer view of how the objects are implemented or how they are represented in the finally and the memory. Okay, so these functions are given for us to do that kind of a manipulation. When I say manipulation, then you need to have a mutable array that is coming out so that you can manipulate it. Here you are getting the byte array, but you cannot manipulate it. Okay, you can only, it's a read only. So we have both the versions of that image of how the object is looking like. Okay, now byte array method returns a byte array object, like how zip was returning a zip object. It returns a byte array object, array of bytes, which is mutable. As I said, byte array is mutable. A sequence of integers in the range of 256. Okay, it's a limit of this much is there, 0 to 255. Okay, less than 256, so including 0. Okay, I'll show you some example how this can be understood. Right now, don't worry about this. Now, if the immutable version of the byte array is needed, suppose you want a byte array created which is immutable, then you can use the bytes function. So both are returning a byte array. This is a mutable byte array, whereas bytes gives you immutable byte array. That's all. Okay, the name looks bytes, but don't think that it's not an array. It's an array of bytes again, but it is a immutable one. Okay, now byte array function converts strings and sequences of integers, okay, sequences of integers and strings into bytes to provide developers the ability to efficiently update or mutate data without additional memory allocation. Now, when you do a slicing of a list, okay, you want to take out a part of it and then pass it out, you can see that there are so many objects getting created on the go. Okay, when this kind of operations are done on a Python object, whereas if you are operating it on a byte array, it's most efficient because you are doing it in the same memory of this object where it is maintaining the object. You are operating in on directly. Okay, if you are modifying it, you are modifying it directly there in that byte array. So it is multiple copies of that is not done. That is, you are not copying into another array and then manipulating it. You are doing it on the same byte array. So it's more efficient in terms of memory usage. If you are not copying and then doing it, then even in time wise, execution wise also, it is more efficient. So these byte arrays are created for that purpose. Okay, based on the need, you may have to look at it, how to use it, where to use it. Or if you look at some implementation in wherever you go in a company, then you can understand why they have used the byte array, the reason behind it, how it is done internally. So that kind of a basic understanding of why someone is using the byte array will give you broader idea of what you benefit by using it. Okay, here it's basically to improve the efficiency because you are not creating a copy of that in another memory. You are manipulating it directly on the object memory. Because it is going to give you some reference to those bytes where the object is getting maintained or being maintained. So though it doesn't give you the actual address of byte array, it gives you access to it. Okay, properly using some indexing or some proper Python syntax, you can access them. It's not as bad as a wrong pointer or no manipulating pointer or corrupting the pointer that you normally be happen to do it because of some mistakes in the C program. Those things are avoided. At the same time, the benefit of directly manipulating the memory is provided so that you have a better efficiency in terms of doing the job. There are no multiple copies of objects maintained or done, so you effectively manipulate or modify or update an object efficiently without the risk of going wrong. So there are some limit checks are done. It's not array limit going out of the limit of arrays that we normally do it in C. We don't do it. We don't happen to do that because they are don't. Though they are giving you access to the memory, there are some restrictions also so that it is safely done. Okay. So bugs are minimized. At the same time, efficiency is also as closest to what you see in C. Now, suppose if you are creating a byte array, you need to know exactly how you are going to encode some string. Suppose if you are passing ABC, you need to know exactly this A is going to be represented in the byte array. These three values are there, but how are they going to be used, represented? So either ASCII encoding is done or UTF-8 encoding is done or UTF-16. There are different encodings are done. So based on the string value, you can encode it in the byte, maybe a single byte or 2 bytes. UTF-16 means it will be 2 bytes, but different encodings can be mentioned. That's what it says here, that you can actually construct the byte array using any of those encoding. Okay, so you are bothered about exactly how it is represented in the memory image finally when the object is created. So this is the little bit of errors also can be given, but I'm not going into the details of that. But at least we'll see how byte arrays can be used and what is this limit of 0 to 256 when we look at the implementation now shortly. Okay. Any questions? Anyone? Please stop me as usual. Now let us maybe create another function. I will close zip and sum. Okay, this is session. Oh, sorry. Okay, so as usual, we will use our function. So what am I doing? I have a list of primes 2, 3, 5, 7. They are numbers. Now I'm going to create a byte array object of primes. So I'm creating a compact byte array of these numbers, which is a list object, which is given in a list object. So what I get is a byte array prime. Now maybe I can print the length also. So let us print it. Now when you print a byte array, it's not a string. Okay, string is different. It will be printed as a double quote or a single quote. But if you are printing a byte array, you always see that it prints B followed by the string, and then the syntax is given like this. Okay, the exact values are printed in hexadecimal format. Okay, because everything is a byte, you can represent it from 00 to FF. So always it is printed in hexadecimal format, and the values are, because we are giving 2357, it's prints as slash x 02 slash x. Don't think that x and slash are stored in the byte array. What is stored is a binary form of 02. That means 4 zeros and then 0010. Okay, that's all. It's just a, it occupies 1 byte. That's why you see that length is 4 bytes only. It is not storing this slash or x ASCII of these values inside them. What is stored inside is exact value of a binary representation of these values, and it occupies only 4 bytes, and it's a class of byte array. So what we have done, we have actually represented this whole 2357, which is a list object which would have occupied a lot of space in memory, into just 4 byte of locations by creating a byte array. Okay, so effectively we are saving memory in terms of storage, as well as manipulating it, operating it on, if whatever you can do on it, then we save time also in terms of operating on those byte arrays. So let us now look at what all we can do with that byte array. I can iterate over it. Okay, though it's a 4 byte locations in the memory, I can use all my higher level language primitives to go over the bytes. Okay, so you get the values printed, okay, bytes. So it's easy, better than maybe array index is also okay. We can even index it similar to array what we do in C. I can index it using that because I know that there are 2 values. Now maybe I have not tried it out of index. As I told you, we have the problem of accessing it outside the number of values. We have 0 to 3 only because we have only 4 values we have created, and the byte array length is only 4. We saw that. Now I am trying to access the 5th element. Let us see what happens. Byte array index out of range. So though it gives you the flexibility of accessing it as a byte array, it also has a control on errors. Okay, you cannot go overboard. It takes care of error conditions. So that's the beauty of giving you the flexibility of memory, less memory usage, at the same time safety also in terms of accessing it. So you cannot access it at the same time. Even if you try to write into this byte array beyond this limit, it will anyway going to give you error, which I can ask you to do that. Now, can I modify it? Because I said that byte array is mutable. So I am getting a byte array. Okay, I am getting the length, indexing it, and I am trying to now use the old value, whichever is there in the prime numbers. I am multiplying it by 10 and writing into the same array. Okay, I am writing into the same array. Is it doable? So since I said that it is immutable again. Sorry about it. It's a mutable object, so I can modify it. So I can see that these values are modified, but I am doing it on the bytes. Please remember, I am doing it on those 4 bytes and multiplying it. Now, what if I try to make it bigger than those values? Okay, because it's only reserving a byte, right? Now that's a limit coming there. Okay, now let us try to do that. What happens if I am trying to write into it which is going beyond that value? Oh, sorry, yeah, this is not the one. I should modify it. Maybe I will do this. I'm trying to write into those bytes which takes more value. Okay, it's not possible to represent this 1000 into that. I cannot write into the byte. Okay, it is going to be beyond 255, which is the limit of a byte. That's the limit which I showed you. Now you see that byte must be in the range of 0 to 256. Okay, see here, range of 0 to 256 actually it means that his own range generator object, which actually includes, it doesn't include this value 0 to 255, which is 0x 0 to 0xff. Okay, it doesn't include this value, but they think that we are all Python guys, so we'll understand the range when they mention it like this. So do not get confused that 256 can be written into the byte. It's not possible unless you have one more bit apart from 8 bits. So you get error when you try to exceed that limit. So that's the limit which I showed you here. Okay, this is the less than 256. That limit is coming because, I'm sorry, that is limit is coming because it is only a byte value. Okay, so I hope this is clear. This is the error condition. If I try to write into a byte which is more than 255, it's going to give an error. So let me comment of this. So when you are handling byte array, remember that the values what you create should be within that range. Otherwise, you will get a runtime error. You don't get a interpreter doesn't catch it. Okay, compiler doesn't catch it. When you run it, it gets into a runtime error. So that is very dangerous. So better be careful when you are handling this byte arrays that you don't exceed the limit. But at least it catches it. Okay, it's not in C it will go unnoticed, but here it will be caught. Now what I do, bytes. Now I mentioned that byte array is mutable, bytes is immutable. So I can print it, I can create a byte array like what I did, okay, but I cannot modify it. If I try to modify it, what happens? I have captured it here. This byte array is also a byte array, but I cannot write into it. Okay, bytes object does not support item assignment, so I cannot assign anything. I cannot modify it because it's an immutable byte array. Okay, because I did bytes. Okay, I did bytes, not bytes, byte array. So that's the only difference. Otherwise, I can do the same thing like the print. If you print it, it will print you the same like 0x something. You know, it only length will be 4. All of them will be same. Okay, so there is no difference between bytes and byte array, except that is one is mutable and another is immutable. So now what do I do? Other things, can I do it with some other things? Let me show you what all you can do with the byte arrays. Now, when I don't know whether I mentioned it, is a byte representation of ABCD string, byte array representation B ABCD. If I pass it to the byte array, it creates a byte array, and then I can print the characters of byte array. Okay. Now you see here this character is printing the actual values of ASCII values. His default ASCII is taken. So small a is 97. The encoding is default is ASCII. So you get the ASCII value of those things. You don't need to ORD. You don't need to do because you are accessing the byte array. So it will access the values stored in the byte, which is ASCII encoding. Okay. I hope that is clear. Now let me show you something else. What is this? Byte array using a iterable object. So can I create using a iterable object? I create 0, 1, 2, 3 and construct a byte array. So that is also possible. Any iterable object can be used to create a byte array, and then you can print it, which is 0, 1, 2, 3. Okay, very simple thing. Now okay, so we can create a range of up to 255, no issues. You can create all this, but if I try to do more than that, because byte cannot keep more than 255, so it will give you error. So this we can uncomment it and see for error. Byte must be in the range of this, so that I already demonstrated it. That's all. So byte array and bytes, I hope you understand what we are trying to do. It's some representation from 0 to 255 you can do, and you can convert from one to the other. You can modify it. You can do an indexed addressing of that byte array, and you can do different encoding. ASCII is one which we all of us follow, but you can do any other encoding also. That's all I have about bytes and byte array. What the time? Okay, we have enough time. Any questions so far? Okay, no questions. Okay, let me take it once again. Who did that? Mukesh, okay. Oh, sorry. That import needs to be always in the first column. Okay. So, what is that? Okay, yeah, you are comparing. Once again. Okay, let it be there. Oh, I need to print it. Is it showing you a bigger size? I may made a. Once again, let me try to understand. Okay, let me tell you the. I don't know where is the size of 61 coming. The reason for this is I can explain this for a why it's not exactly 4 bytes. Okay, let me show the length. What does it give? That is 4. Now size of byte array is 61. Is it yeah, size of is always in bytes, I think. But the 61 looks very odd. Okay, let me increase this and see. Does it increase or not? 64. It remains the same. One second. Let me try to understand what is happening. So there is a fixed overhead in the byte array object also. But okay, let us see the size of list. Okay, is that yeah, we are not printed the size of list. So let me print the size of list.
Sir, it is 88. I send a chat.
Sorry. Oh, you have put it there, is it? Okay, let me for the benefit of everyone, let us print it here. Size of list. So how does it? Okay, size of list is 128. This is 68. How does it change? Let us see. What was the previous one? I forgot. Okay, one second. 128 and 60. Okay, this is 128, 68. If I reduce it, 120. So it for every element I add, it goes by 8 bytes. Okay, because it's internally, I think 64-bit Python machine, or I don't know the reason. Here, this is going much slower compared to that. Okay, let me. Okay, so if I have to explain the reason for this, okay, one thing is it is byte array is more efficient in terms of memory compared to any other higher level of data structure objects that we have, which is obvious. and the increase in this is tremendous in terms of you get every element that you add to the list is adding 8 bytes here, but this is growing much slower. So you can imagine if you have a huge list of elements and if you convert it to a byte array, it's going to be occupying very comparatively very less memory compared to any other objects that you have. But you may wonder why it is not exactly this. Okay, anyway, it is going to occupy only the bytes and then we are limiting it. Okay, let me try to put a value which is more than that. Now what happens? So somewhere catches when you are trying to convert it to a byte array. It 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 stops you. Okay, so that means it is going to store these elements as a bytes only, but it has a fixed overhead for a byte array object, which is I am okay. Now let us list no element. Suppose if I have a byte array with no element, how much is takes byte array equal to byte array. Okay, b null. Okay, ba null byte array. Thanks for bringing it up. Okay, it opens up a lot of interesting stuff. What is happening underneath? Sorry, what I did. Okay, I should have. Oh, sorry. Let me create a null list. Hmm. Okay, now, okay, this is a limit. Okay, let us remove this guy. Now, what is a fixed 56? Okay, now let us add one element 58. Let me add two element 61. So it goes. So we have seen that 58 is the now it remains same 61. So they do some optimization in terms of memory, okay, in a element, but fixed overhead of 58 bytes are there, which is internally they have to maintain. See, I told you that it maintains range, out of range it catches. That means there is some mechanism to provide, check whether the value is going out of the range or you are going accessing the element beyond the range limit, byte array limit. That means it has to maintain the length of the byte array somewhere. It's not as equivalent to the byte array. If I have mentioned it, maybe I should correct it myself, that it has some overhead to keep track of those error conditions. Okay, what we normally get into, it's not possible unless it maintains for every byte array object, it maintains internally the length of the byte array that you have created, so that when you are indexing it beyond the range, it catches it. So it needs to maintain some information about the byte array. So that is a overhead that we see. 58 bytes, what we saw is a overhead, but as we can see that it much more efficient in terms of by size. Okay, it's not exactly 4 byte it maintains when you say array. Okay, I can make sure that I hope I have not made a wrong statement here, and the reason also is because it needs to have some error checks that you don't misuse that byte array anywhere. Okay, I hope Mukesh, I have answered your question. Okay, geeks. Okay, get size of calls the object size of method and adds an additional garbage collector overhead if the object is managed by the garbage collector. Wait a minute. Calls the object size of method. Okay, and adds an additional garbage collector overhead if the object is managed by the garbage collector. See, garbage collector overhead means it needs to recover the memory. So in that case, when you say garbage collector overhead means it has to maintain some information. So when it is getting the see, normally I'll tell you one more thing. What they do is because this byte array is mutable, you may add more element to it, or you are going to increase it. So what they do is, when they are allocating the space for that, they allocate little more than what is needed, so that they don't need to copy this object again into a larger value. Okay, so that kind of optimization they will do. And then they may also do, if the memory what they are giving you, actually I'm surprised to see that 61 bytes and all that, but it will should be a multiples of 4 or something. I don't know really internally what they do, why the 61 byte length is coming. But it always some overhead of increased memory will be there. So let us try to see what is given here. uh, Get size, and what is the difference between get size of and can be done to find storage size of a particular object. Okay, I get size and size of, what is that difference? Does it return the same value? Guys, you know that? Anybody? I am seeing the get size first, so let me get size. What is the difference between these two? Sorry. Okay, maybe it is deprecated. Where is that link? How do you use it? Sys get size of 4. Actual 28 bytes. Okay, oh, object has to be created faster. Oh, that's what I'm doing. Why is it module sys has no attribute get size? So get size is gone, I think. Get size of is only there. So maybe that's a very previously supported function. Okay, so any other pointers? Anybody wants to share anything? Anything newly found? Where are you guys? Okay, checking more on byte array. Okay, very good. Please pass it on. Okay, very interesting area this is. If you go get deeper into it, maybe you will know the reason why some sizes are. What is this LI? Okay, 88. Okay, fine. But it's again implementation dependent. Okay, we can, you please share some information, interesting information, if you come across, Mukesh or anybody, you can share it with me. I'll be more than happy to know about it. Okay, so nice that type of the object, yes. But here, what do you mean by type? It's a byte array only, no? I don't know what the type of the object. It's only a byte array. Okay, what object you are converting into a byte array, you are saying. Finally, it is the list of bytes. Okay, sorry, array of bytes. I don't know whether that is dependent, but anyway, please pass on any other interesting information you come across, and I'll also look for it. But this overhead is understandable, because it's not exactly the byte array addresses. It's always true in object also, even string object also. You can see that string object size also is not exactly same as length of the string, because of the overhead that is always involved, because they need to protect your object from misusing it or by erroneously corrupting it. So they need to have some additional buffer, whereas C doesn't have those control, and it just trusts the developer that they will use it efficiently and correctly. But Python puts lots of checks on it. That's why you see that there are some increase in size, but it is certainly byte array is more efficient in terms of memory usage compared to other objects. That is very obvious. I am sure all of you are convinced about it. I am convinced, but in case if you find something contradictory to that, please share it with me. Okay, fine. I think we don't have time to look at the memory view with the 10 minutes remaining. We can defer it.